Okay, looks like we are live. Hello, everybody. Good afternoon to our friends. Hello, friends in Australia, whichever city you are, and good morning and good afternoon, and maybe good night to some other friends wherever you are joining us for our November meetup this month. Thanks for joining us. Welcome to our November meetup, and thanks again for coming along and sticking to our community for another good session around all around Azure stuff this month in November. Yep, as usual. So let's go through the agenda for today. So let's talk about the upcoming events, which is really not that much this month, because we are approaching end of the year and we're going to wrap up another rough year and hopefully having a bright year next year. We'll see. And then we go to what's new on the Azure platform and a couple of announcements and updates speak from us, very specifically focusing on the developer workspace. And then we have our awesome guest speaker, Patrick, to talk us through around building the enterprise-grade API gateway microservices using Azure Services and Ocelot. Okay, let's move on. Yeah, as usual, also you can see our contacts on the screen. If there is any questions all the time, please pop them in. Our friends in the background can pick them up and can answer them, or if it's required, can be directed to our guest speakers when it's required, or if we can be of any help to answer them, more than happy to do that. All right, okay. Yeah, in terms of the upcoming events, new breakpoint, if you are not familiar, it's a video cast. It's like a video show by Simon and the team from Microsoft Australia. The new episode is coming out on 7th of December, and it's all about focusing for developers on the OAuth and new authentication platform and JWTs and what you can achieve and what you get from the Azure Active Directory perspective. Always on, always online, always available. Cloud Skill Hub is another thing. So you can find that's a centralized platform by Microsoft for everyone in the every skill and any tech stack from the Microsoft you want to upskill yourself at any different level. So go there. There are different training, different events, online events, which you can use to upskill yourself in whichever tech it's interest to you. And as usual, we are more than happy to give away Azure passes and which is $100 Azure credit, which you can use for getting your hands on the Azure environment, if not already. Or if you know anyone, then you want to encourage them to start using Azure environment or exploring what Azure Cloud Platform is, yeah, please reach out or direct them to us. More than happy to give away for another 10 Azure credit or Azure passes this month as well. In terms of the private preview announcement, there is only one, which is the Azure Open API services. Azure Open API services basically is a new member of Azure Cognitive Services that provides you access to Open APIs, GPT-3 models and platform, which contains enterprise capabilities such as like a security, enterprise compliance, and regional availability also that are available only on Azure platform. And you can apply these models to your mission critical applications when you run them on the Azure Cloud Platform. At the moment, it's by invitation only. So if you are interested to explore and see what's in there, you can fill in the form and see if you get accepted for the private preview invitation. In terms of the public preview, the Ignite was happening at the beginning of this month, November, and there were a bunch of interesting announcements and updates in all across the Azure platform, including all the services, data, app, infrastructure, and different areas. So we have picked up few of them, which we think more interested to developers, and let's go through them. The first one, which is super excited one, and is the Azure Container Apps. It's another new family member to the Azure App Services. Um, and basically, it's a managed serverless container service, which offers a platform for application and serverless platform for application developers who want to build and run like a microservices applications or APIs in a in containers, but without worrying about managing any infrastructure or anything on the Azure Cloud Platform. So purely focusing on the development and in a serverless way. It comes with heaps of awesome features as well, which you can get, such as you can use any preferred programming language as you want. You get the cloud scalability and dynamic scalability based on the HTTP traffic which comes to your application, or based on the events. So it's an event-driven architecture as well, and plus few other additional things which is very helpful when you want to manage a modern application lifecycle. For example, application upgrades, versioning, or traffic shifting, like a blue-green deployment, and such things that you can see these days in modern application lifecycle management. Azure Functions got few updates. The first one basically is around the SQL databases, and now Azure Functions can interact with SQL database through input and output bindings for Azure SQL. Configuring these bindings is easy, and basically with specifying a couple of parameters, you can achieve these input and output bindings. For example, specifying connection string, or what query from DB you want for example, for the input, or the table as the destination when you use as an output binding. Another one is support for Node.js version 16, which is now in private preview in Azure Functions. And also PowerShell on Linux OS is also is announced and updated, available in Azure Functions for consumption and Elastic Premium tiers, which is now available, and you can use basically using your using a PowerShell and host them on the Linux OS with Azure Functions. AKS also got a couple of interesting updates. Two important ones which we picked is the Dapper extension. If you are already familiar with Dapper, or already using it in production or exploring it, Dapper is it's kind of an interesting. It's a portable event-driven runtime that makes it easy for you or for any developer by any language as a preferred programming language to build a stateless and a stateful applications. And it's great to tackle the challenges that you may face in building microservices application, microservices style kind of applications, and helps you keep your code platform agnostic also from wherever you want to host it, even if it's a Microsoft Azure platform or other cloud providers, or even on-prem. So this extension adds the Dapper provisioning. This is a specific extension on the AKS, adds the Dapper provisioning, which contains setting up, configuring the runtime, Dapper runtime on the cluster, and eliminates all that overhead from you. And basically, you get that as an extension when you set up the cluster. You can enable that one and add it to the cluster, which reduce the overhead of setup and managing the Dapper runtime in your AKS cluster. Another feature is node pool start stop, which is now extended and expanded to support user nodes as well. Node pool start stop is a very useful capability in saving time and cost when you are running a AKS cluster, specifically if it's not in the production, and basically allows you to completely stop a specific user node pool and pick it up later on from that point of time that was left off. That's a great feature, as I said, for costing time and saving time and cost when you are running cluster, specifically with huge nodes, and you don't want it as an always on cluster running on. Yeah, as I said, if there is any question, please pop them in, and our friends in the background can pick them up, and we can get back to that later. Few other things gone in public preview and now available in the public preview. Azure Logic apps in the standard tier received few updates and offers few announcements also. Now the standard tier is equipped with the new Cosmos DB Logic App standard connector as a built-in connector. So now that connector is supported and available in the Azure Logic apps as a built-in connector, which means the connector is hosted in the same process as the Logic app runtime. And from the performance and efficiency, that's a great update, and basically offers higher throughput and lower latency and better local connectivity between your runtime and the connector also. You can now also run Logic apps in a fully disconnected mode by leveraging the SQL as a storage provider for your Logic apps runtime, and leveraging existing, for example, if you have any existing SQL environment set up, now you can extend it and leverage it for this purpose if you already have. And it's very helpful to run Logic apps in a standard plan, fully disconnected and without any dependency to the Azure storage, which is the default storage for Logic apps. Azure API management also received few updates. The GraphQL, for example, you can import existing GraphQL services as an API in the Azure API management, and leverage all the existing benefits which is already available and offers by API management service. Now you can use them for your GraphQL APIs, and plus getting some of the GraphQL specific capabilities as part of this update. For example, query test console or query validation when you are sending the query through the API, or field-based authorization, and there are a few other more if you check the update in the documentation. Also, container apps, which we talked about that earlier, now it's already supported by Azure API management, and that means you can import your Azure container apps as an API in the API management natively. So that integration and connection between container app and API management now is in public preview. Azure Blob Storage SFTP support is a long-waited feature, which I believe probably everyone in Azure was waiting for that one. And now it's basically, in summary, it's a native SFTP server, which is now available in Azure. And now Azure Blob Storage supports SFTP over object storage, completely native within the platform and in a serverless fashion kind of thing in the Azure. So you don't need to set up any infrastructure for that. As long as you have the Azure Blob Storage and you turn on some configs, then you can start using that one as a completely SFTP platform. And this new support provides you the ability to securely connect to the Blob storage via the SFTP protocol or endpoint, and allowing you to leverage SFTP file access, file management, file transfer, and all those features which you get from a typical SFTP service. Azure Chaos Studio also is a totally new service in Azure, currently in the private preview, and basically it gives you capability to intentionally introducing fault to your system, to your application, and simulate real world scenarios. For example, if any outage happens or if any network disconnection happens, or there are few scenarios. If you check the service, they already support today, and it's very helpful. It helps you to improve the resiliency of your application by simulating the real world outage scenarios, and by tracking and measuring and mitigating those faults when you experience them. Another one is the GitHub Action OpenID Connect with Azure AD support. uh, but what that means is basically this is a new capability added in the GitHub platform, and it enables you to leverage the OpenID Connects integration between Azure AD and your GitHub action, and it simplifies and reduces your management for cloud credentials. For example, if you use service principals in the GitHub to connect to your Azure environment. And that requires, for example, storing the secret in the store at the GitHub side, and make sure it's not expired. And if it's expired, it causes the downtime to your GitHub actions, to your workflow. And by this leveraging the OpenID Connect, you can mitigate all of those, and without needing any using any service principals or cloud-based credentials for that one, for connecting Azure environment to your GitHub action. So these are public preview. Let's move on to the GA. The very first important one is the .NET 6. So .NET 6 is released this month, early this month also, with the long-term support included, and it's now available in the Azure platform and supported in the app services, Azure Functions with runtime version 4, and static web apps also across all regions. So that's now available if you want to upgrade your application to .NET 6 and start testing them, or even if you want to promote to production as well. Azure Functions runtime version 4 also is GA, which is a new update to support multiple new runtimes and new languages. As I said, for example, .NET 6, Java version 11, PowerShell version 7, and a few other things which comes with this new runtime version for Azure Functions. Custom OpenID for App Service and Azure Functions also is GA now, and that means you can use any OpenID provider for the purpose of application authentication, and add it as a custom identity provider to your app service or Azure Functions. API management, WebSockets APIs. So that's GA. That's another update for the API management service. Now API management supports WebSockets APIs fully natively, and which allows you to manage, expose, and protect any WebSocket APIs if you have completely in a native mode within the Azure API management, and similar to the way you do with, for example, REST APIs, or if you have any SOAP APIs, it's treated exactly in the same way, and you get all the features available from API management for managing all those WebSocket APIs as well. Logic apps got few updates in the GA, apart from those we mentioned in the preview. A bunch of connector updates happen on the Logic apps. And for example, there is a new connector for SFTP with trigger supports, rather than pulling and checking the SFTP folder to see if any files is there. So that's a good for any file-based scenarios or workflows. Another good one is Service Bus Connector also got an update to allow implementation of advanced messaging patterns. which is introduced to the service bus. Cosmos DB connectors also got a new update, which is completely renew based on the new Cosmos DB SDKs. And another important one, for example, for all the connectors is now they support managed identity based on the target service which you want to use, and if they support managed identity, so you can leverage the managed identity to connect and authenticate to those services as well. Cosmos DB Cassandra API also got 2 updates, few other updates, but we mentioned 2 of them here. One of the important one is the name indexes. If you are using Cosmos DB with Cassandra API, with name index updates, basically Cassandra API fully supports name index, and which allows you to define a new index with a name on a single column. So that update is in GA now. Glowroot also is now supported natively in the Cosmos DB Cassandra API. And Glowroot basically is an open source APM tool for monitoring and optimization of the performance for Java-based applications. And now with this update, Azure Cosmos DB Cassandra API, you can monitor the application performance with no need to update your application basically, and to glue to do all those glue thing to support the glue route to your application. So now it's native. That integration is natively available within the Cassandra API for Cosmos DB. Another, I believe, the last slide. Azure App Service Environment version 3 now supports Windows Container. So that's a really good and important feature which comes to the app service, because it helps you if you want to, for example, modernize or migrate your on-prem application, which are purely Windows-based. For example, if you are running on the Windows server, now you can use the Windows containers to containerize them and bring them to host on the app service using the app service environment. So that's a great feature for modernizing your workload and bring them into the Azure platform. Azure Service Bus large message support is another quite important. It was it went in preview a couple of months ago, and now it's in GA. And basically, it means Service Bus already support. Currently, so far, Service Bus already supports sending and receiving message payloads for up to 1 megabyte. So that's a limit for all the tiers available within the Azure Service Bus, even if it's a standard or premium. By this update, if you use Azure Service Bus Premium, you can basically overcome that limit by sending and receiving message payloads for up to 100 megabytes. So that's an improvement, but it's only available in the premium tier. So a standard tier still stick with that limitation for 1 megabyte. Azure Cosmos DB also got few updates in the GA. 2 important one is partial document updates, which again was in the preview a few months back, and now it's in GA. So that update means at present, Cosmos DB, when you update some data within the document in Cosmos DB and you send the update back, so it replaces the entire document, and it happens. That's how it happens currently with the update operation. This update is to optimize that update operation, and basically with the update operation now you can specify what data has changed. And what Cosmos DB does is basically look at all those data section within your document and partially update the document, which is really grateful and helpful for efficiency, for improving the throughput, and basically reducing the network payload size, which at the end result has a better efficiency and performance improvement to your application. And Yep, provision throughput spending limit, which is another great update, which is GA on the Cosmos DB. And basically, when you provision the Cosmos DB, you can specify your spending limit, and uh, it's good for avoiding the, for example, bill shock or other costly things that comes to the Cosmos DB. So that's another important update in the Cosmos DB area and on the Cosmos DB service. Any questions so far for the announcements? Yep, I'm not sure if we have received any, but let's talk about the announcement and useful links. So if back in the days you started to use Azure Scheduler, uh, it's I believe 2 years ago or maybe 1 year ago, there was one announcement that they're going to retire this service, but they extended to 31st of January into 2022. And so that if you still have leverage that service and you still have workload that use that service, it's better to think about that one before the service completely gone. And the recommended approach for that is using the logic apps, or if has another advanced version, you can go probably with the Azure functions if you want to replace that one. New Breakpoint show, we already talked about that one. Monthly community newsletter, also it's another great effort by Microsoft Australia team, which provide the curated content, focus on the developer tooling and developer content from the community. We plus few other things. For example, if any new things happening in the events or in the Microsoft space, also you can get notified if you subscribe to that community newsletter, which is a monthly newsletter and you receive it monthly. And already talked about the Azure Pass. So you can see the link on the screen. If you see, if you need to get the Azure Pass, which is $100 US credit, as I mentioned earlier, go to that link, which you can see on the screen. Sign up, review, and we assign you. Or if you know anyone that requires to get hands-on on the Azure environment, yeah, more than happy forward the link to them and just send the name to us. So after that, after we review, we can allocate them one Azure Pass they can use. But the important thing is, if you already activated one Azure Pass with your email address before, you cannot do that again unless you go with new email address or yeah, another strategy. So that's so far from us for the first part, which is what's new on the Azure. So I'm not sure if there is any question. I'll check in the background and we can get back to that one. If not, let's take a very short break and then we can have Patrick from SSW Consulting. So Patrick is a solution architect with SSW, and he's going to talk us through how we can build an API gateway, enterprise-grade API gateway, using Azure application services and Ocelot, which is open source framework for enabling that one. Yeah, waiting for this great session. So that's it for now. Yep, let's bring up Patrick. Hello, hi Patrick.
Hi there. Sam, can you hear me?
Yes, very clear
Awesome.
and perfectly. Thank
Cool.
you. I disappear. I'll leave it to you. Wherever you feel you feel comfortable, you can start. Thank you.
Yeah, sure. Thanks, Sam. Thanks, Arafat, for your warm introduction and invitation for Azure Senior User Group. And to be honest, this is my first time presenting on Azure Senior User Group. I did I did love user groups. I did few presentations on Melbourne user group, and it's my first time. So, hello everyone, senior user group attendees, no matter where you are, good day. And before I get started, I just want to bring up some buzzword that I heard from Sam's updates. That what's that the latest from Azure. We can tell that Microsoft Azure has been investing more and more in the microservice and serverless computing sort of area. For instance, the API management, WebSockets supports, it's in GA now. And a lot of those services in microservice space can help us to build a better microservice architecture or enterprise solution on Azure. Now, let's get started. Today, I'm going to talk about how we can build an enterprise level microservice solution using just give me a sec, using Ocelot and Azure. We can see this lovely Ocelot has got a set of really Azure eyes. I'm Patrick. A little bit more about myself. I'm a senior software architect at SSW. I'm a full stack engineer and speaker. Here's my Twitter. If you want to be a bit more, formal, you can connect me on LinkedIn. And at SSW, each consultant has his own profile page. You can easily find me by Googling SSW Patrick. All right, so in my spare time, I like to contribute and follow some great open source projects. My recent interest has been doing an open source chatbots project, which can help an organization to set up a virtual reception desk so that when the visitors are coming, they can look for an employee in that organization with certain skill sets and availability without too much hassle interacting with a real human. It can all be done by chatting with a bot via some console. So if you have the same interest, you're welcome to my GitHub and see my activities. I do also have a personal blog. I see it a great place for me to every now and then retrospectively summarize the lessons I've learned in my recent project, some great ideas that I can think of or I follow. Now, before we get started, I'd like to show you the agenda. First of all, I'd like to talk about monolith and microservice, and we're going to do some apple-to-apple comparison. Monolith might not be the monster, while microservice might not be perfect. Let's see the ins and outs. And then we'll have a deep dive into microservice and see each individual elements that make up an entire microservice architecture and how we can start your journey on microservice. And then we will be more specific to talk about microservice on Azure, what type of Azure services can help us in building our microservice solution. And as usual, I have prepared a demo that serves as a POC. Once we have our requirement, we are clear about the architecture, we can do some hands-on and have fun. Now, with all my honesty, I have to say that this presentation was given on NDC about a week ago on a paid track. So if you have attended NDC and you have listened to my session, you're welcome to jump off, and we are still welcome, but there won't be too much new stuff here. Whereas if you haven't seen my NDC session before, this is a great chance for you to deep dive into microservice world. Okay. So what is monolith? As monolith architecture means a bunch of Lego bricks which are completely unorganized in a mess and very hard to figure out what we're doing. Actually, it's not. Monolith architecture is actually a standard architecture, and it's a unified sort of pattern for developers to easily get started and build a solution. So as we can see, from bottom up, we have database it can be your SQL database, Microsoft SQL, MySQL, Postgres, whatever, or non-relational database like Cosmos, MongoDB, etc. And you have a data access layer or data interface that interact with your database to run your command or queries and get data. And then one level up, there's your business logic. You can have a lot of classes if you talk about C#, or a lot of modules if you talk about Node.js to implement your business, and then it will serve up, interact with your user interface, presentation layer, your controllers, and then return to your front end and present it to the user. So it's pretty straightforward, and each single action can be done via a transaction script pattern. So your logic might grow, but the way you implement are pretty much consistent. Although complexity may be another issue, which I'll touch on in a bit. Now, so once we have a brief understanding of monoliths, I'd like to show you the pros and cons. So first of all, a monolith application, just from the name, we can tell that it's self-contained. Once we've built a monolith application, it can be very big, but regardless, no matter we spend 1 minute or 1 hour to build a monolith application, the end result is always an artifact, and that artifact is self-contained. Once we deploy that to an environment, it's going to guarantee to run in that environment, and only one environment. All right. So I see this is a positive sign of monolith solution, because we don't need to worry about a lot of different hosting environments for different services and cross-cutting concerns. They are all self-contained. And apparently, it's easier to test and debug. Mind you, this is talking from a outside perspective, meaning we treat the monolith application as a black box. So once we deployed or we've spin up a monolith application and we treat it as black box, no matter whether it's wired up or twisted in itself, from a black box test or integration test perspective, we can give it an input and we can assert on the expected output, and that's it. And when we talk about debugging, it's, as we can see from the previous slides, the round trip the path of a round trip traffic is clear, so it's easier for us to step through each layer. And with that, it has a less overhead in cross-module communication, because when you try to reference some method in another module, you are basically referencing it directly from a C# class library. And with above, we can see that if we want to get started for a greenfield project, especially when we are not so certain about the scope or what it can potentially grow in next 5 or 10 years, it's easier to get started with monolith architecture, because there are less infrastructure concerns and less services to spin up. Now, on the flip side, there are cons as well. So the biggest disadvantage or problem with monolith architecture is that usually it will be tightly coupled, especially when it's done wrong. Mind you, the exception here is if we've done monolith architecture in a modular way, that is what we call a modular monolith. The monolith architecture can be loosely coupled, and if we introduce some nice programming patterns, aka clean architecture, such as CQRS pattern, event sourcing pattern into a monolith application, then it can potentially be done properly and loosely coupled. Now, the next one is, it tends to be more difficult than microservice architecture to update individual feature, because in the code, you might have a shared module that's referenced by class A and also B, where your class A may be injected to class B, and because they share the same domain level, in theory you can inject one class to another class in the same layer. So if we try to update one single feature, it might have an impact on other piece. So basically, you need to run your test to make sure that your change does not fix one problem but bring in another problem. So to add on that, similar to the first downside, if we've done it properly, it can be avoided. So once we've introduced those clean architecture, the individual feature sits on itself, no matter by some nice coding patterns such as CQRS or factory pattern, then it's easier to maintain. Now, there's something that is a hard roadblock in monolith architecture is that we would have a massive code base because we want to build the artifacts in one go. So our code base is in one single repo. The storage or your Git actions like push and pull will not be a problem because these days computers are super fast and has a very good performance. However, in order to understand a code with, 10,000 lines of code, you really require a holistic understanding before you jump in and get started to add a small feature to it. And same as the scaling, you can either scale the entire solution or you scale nothing. That means that we might have some unnecessary cost, especially when different parts of your system / different features require different level of scaling at different period during the day. Then it's unnecessary to scale the entire solution to satisfy a small piece of the code. Okay, so then we've understood the pros and cons of monolith. Then I'd like to talk about why and how usually organizations migrate from monolith to microservice. The biggest reason from my observation is in a legacy system migration, especially when we are migrating a enterprise level application from a big monolith application to a latest tech. For instance, from some old school, WinPhone to a modern Angular, React, or Blazor. Then no matter from the architecture perspective or from the project management perspective, it's really risky to migrate the entire system in one go. Because it might be hard to estimate the overall scope because the application is too big. So in this circumstance, usually from an architect perspective, we're going to propose adopting the microservice architecture in the new application, which uses the latest technology. And we migrate bits by bits so that this way we can work out different milestones of your project. And we call this a strangler fig pattern. So this is where microservices come into play naturally, because we have to migrate the monolith in a micro way. And the other main reason that why we want to transfer from monolith to microservice is for the scalability. If we want to have a more flexible scaling story and a scaling strategy, and also a better way to manage the costings, then microservice is better than monolith. And the other thing is more from a development or production team's perspective, that we tend to have a better productivity out from the developers on a microservice development team rather than monolith development team. Mainly because that for a developer who look after a microservice, he doesn't need to understand the entire business. He can be onboarded relatively quickly, because in order to look after a single microservice, I only require that amount of domain knowledge. Okay, so here, Lego Bricks again shows you a great example of a major difference from monolith to microservice and how we do the transition. Now, if we look closer to this diagram, we'll see that in this Lego pyramid, if we were to troubleshoot or replace this green block, if it's been corrupted or for whatever reason, we need to replace it. If it's a monolith pyramid, what we need to do is that we need to put down at least the top 3 layers, and then we fix this green block, and then we reassemble it. So it's time consuming, and it's not easy to manage. So whereas with microservice, if we are going to replace one block, we only need to troubleshoot this small piece. And usually the way to migrate a big monolith system to microservice architecture is by a closed look and analysis on the individual modules within the monolith system, and group them to a logical group, and so that when we spin each individual logical group up, they together make up your solution. So they serve the same purpose from a user's perspective, but microservice provides a better way to organize and to manage your code and your project. Okay, so we had a brief overview. Let's get on to the key elements that makes up a microservice. So first of all, we will have the API gateway that serves as a single entry point. And by talking to the API gateway, our front end of different types, made from of different technologies can be supported, such as web or desktop or mobile. And no matter what kind of technology they are implemented in, PWA, Electron, Cordova, whatever. And we want to have a flexible deployment model in the subsequent microservices behind the API gateway. So because API gateway in the microservice architecture serve as pretty much like an orchestrator and a gateway, as what the name suggests, that it hides the complexity behind it. So it gives us a flexible way to deploy individual microservices. Either we can spin them up as normal web API or containerized application in your Kubernetes cluster, or a service running on IaaS on your on-premise server. It doesn't really matter, because from front-end perspective, it only communicates with your API gateway. And it's your API gateway's job to communicate, offload or fan out, etc., with the subsequent microservices. But an important thing for microservice architecture is each microservice should have its own data store. Now, here the keyword is data store rather than database. What it means is that multiple microservices can talk to the same database, SQL or NoSQL, doesn't matter. But if they are talking to the same database, we need to make sure that they own their own schema. So cross microservice data communication or data fetching should be avoided. That way, it's true microservice that if we change the schema in one data store, would only result in the change in the microservice that owns that data store, rather than affecting other microservices. And usually with microservice, we want to advocate the event-driven coding pattern, because that comes natively and as a good fit for microservice architecture. And usually I like to add a VNet integration to help us to secure our microservices behind the API gateway and provide us a better way to manage the traffic within the API gateway. Within the microservices. And usually we would require messaging system to support the event sourcing event-driven pattern. So that's when different microservices need to talk to each other. They don't talk to each other by calling the method in another microservice directly, but they will leverage the messaging system in a pub-sub pattern. Now here I've got a very good screenshot, a diagram that I got from Microsoft document repository that explains microservice architecture very well in a visualized way. Microsoft has been actively maintaining their documents that shows examples on how to build microservice architecture. From here, we can see the key elements of a microservice architecture. We can have different type of front ends. It doesn't matter which type of front ends, which type of technology the front end is implemented in, but they all talk to an API gateway. And the API gateway can have a variation of backend for front end to serve different front end types of front end. Now, behind the API gateway, we're going to have multiple microservices. For instance, we have a catalog microservice to manage the catalog, and the catalog is apparently relational data, so it's stored in a SQL database, and there might be non-SQL data like your thumbnails of your products, or some legal documents of your products that can be saved in Cosmos, and your identity is all managed in the identity service, and you have an ordering service that has a SQL store as well. Now, when they need to talk to each other, they all leverage event bus. There are different technologies that we can use. We can either use RabbitMQ, or we can, on Azure, there's a managed service called Azure Service Bus, and there are other alternatives as well. I'll touch on later. So that way, we can see that there's no error in between services, or from one service to the data store belong to another service. So this single data store pattern is the key of a microservice architecture. So go ahead and check out this example. It's really good. All right, so from this image, we can see that Microsoft uses Docker to host the applications, but really there are different options other than the Docker deployment. So we can choose platform as a service on public cloud providers. There's no block that stops you from deploying your subsequent microservices as a PaaS service. Or we can even containerize the application like what Microsoft suggested on Docker, or a managed Docker container service on Azure, such as Azure Container Instance, or even there's a new serverless container application called Azure Container Apps that's recently released. And you can use Kubernetes. So your subsequent services are spin up as pods, and you can manage them in your AKS cluster, or your Kubernetes cluster. And on Azure, there's AKS. So microservice does not only mean a software development architecture, but it also means it's closely linked to your methodology and how you build a development team. By that, I mean, by using microservice architecture, we can have a fast onboarding experience with your new developers that you recruited. And the new member is likely to be able to have a quick adaptation to the business requirement change. So if you change a workflow or piece of feature in your solution, you likely only need to touch one single microservice rather than the need to change a lot of place. So to get started, monoliths seem to have a simpler beginning point, so that the development speed is higher when we get started, whereas there's quite a few boilerplates and cross-cutting service and configuration to be set up if we follow microservice architecture. So microservice architecture tend to have a low development speed in the beginning, but as time goes on, microservice the development team's productivity when they follow microservice tend to grow to a certain point. But at that certain point, from that certain point onward, the development team looking after microservice can still be functional and still can add features. It just becomes a linear approach that these amounts of features requires that amount of time, and that's going to be consistent down the track. Now, the monolith is the other way around. So when as time goes on, and monolith architecture seems to slow down the development speed, and when it's passed beyond a certain point, it's going to drop. And at a certain point, when your monolith application grow to a giant, then it's almost impossible to adapt to new changes in the business at all, because it's so complex that it might take a lot of time to explain. To make one change, you have to test 100 different places. It's very difficult to onboard new team members. So that means that application becomes almost unupgradable. Okay, so microservice has an impact on your DevOps story as well. So it facilitates your development to be really truly agile. That when we get a requirement of a small piece of the entire business, you can reflect it in that microservice, and you can deliver and circle back to your stakeholders quickly. And it separates deployment from release. Here, it doesn't mean that we don't have release. We still have release, but the strategy of the release changes from a traditional release to a more progressive way. So here, a progressive release means that we can have dark launch for certain features, and we can toggle on and off a feature flag. So from this diagram, we can see that if we want to toggle a particular feature on and off, we can do so by applying the feature flag onto each individual microservice. If each individual microservice look after a feature. Now, this can also be done in a traditional monolith approach. However, the amount of effort to enable feature flagging and dark launch in monoliths is much higher than microservice. So we've talked enough about the benefits of microservice. Let's look at the dark side or challenge. The first thing is that there's a word called micro monolith. What that means is, surely microservices tend to cut your entire application to different small pieces. So each of them has its own domain. So in theory, each of them would have a small amount of logic stick within the boundary. However, if your service tend to use some shared method, you tend to call those shared methods from each of your microservice. For example, if you want to get today's dates, then we need to call a get dates method, and that method can it's a built-in function in .NET, and this is just an example. that that method might be called by different services. Now, if there's a requirement to modify the shared method, then by modifying that, multiple microservices would potentially be impacted. So the way to avoid this from happening is to properly package and version those shared method as libraries/packages. So in .NET, we like to package up your module, your class library as a NuGet package. So when you make a change or patch to your library, you bump up the version, your consumer across different microservices can choose to either opt that in or stick with the old version. And then you can obsolete certain method and deprecate them completely by different versioning strategy. And in Node.js, there's npm packages for you to package up your modules properly. So once we've done that, we can avoid a micro monolith. And the other thing is the join operation, especially with the reference data. So a piece of your data that's owned by one microservice can potentially serve as reference data in another database, which has the majority of the facts data / transaction data. Then when this happens, what can we do? We certainly can establish cross-service communication by using pub/sub pattern, your message system. Another alternative is your data duplication. So as I said, we can reference external service or we can duplicate data. Each of the approach has its ups and downs. For instance, when you try to reference an external service, that means that your primary service now have a hard dependency on the external service. If the external service goes down, you need to think about how you mitigate that issue. Duplicating data tend to be a better approach because these days storage is really cheap. However, the real challenge in data duplication is that you need to make sure that the data you duplicated from the service that owns the reference data to the destination service, which need to reference the data in a timely manner, so that your data in the main service, which look after fact table, does not become stale before it's completely removed. So the reliability in each individual service need to be looked after and worked out on a case-by-case basis, especially when we have a shared data referencing and shared method. And the last one, which is the biggest challenge, is the domain boundary. How we can slice the cake to a proper degree that both we can define a clear boundary between different units of your business, and also we can make it developers be comfortable to be onboarded to each individual logical group. And this challenge has no quick and easy solution. The only way to solve it is that you really need a good domain knowledge and experience in the enterprise application that you are building. All right, so let's drill down to each individual element. First one is the API gateway. So as we can see, the API gateway here serves as a single entry point that interacts with your end user. And it has multiple subsequent microservices that it needs to coordinate or orchestrate. So what API gateway is that it's abstract the cross-cutting concern of For instance, your JWT token validation, your session management, your cookie, so on and so forth. So we can see it as a big middleware that serves as the entry point and exit point of your application. And a good analogy would be a middleware in C# in a C# web API application, but it's in a service level. Now, it can do a lot of things. From a high level perspective, it coordinates the external traffic to internal microservices and then get response and return to the outside world. So it can either be a proxy that simply dedicate the traffic, or it can have some fan out function. It does orchestration and aggregation when you need to. And we want to support backend for front end occasionally. Now, Ocelot is a very good library for building API gateways. It's an open source library that's very popular in .NET's world. And essentially, it's a bunch of middlewares that's executed in a specific order, so that all the cross-cutting concerns and coordination can be done in a single place. And we spin the solution up as no difference from how you spin up other .NET applications on, especially on Azure. And it's starting to adopt WebSocket. So as I mentioned in the beginning, I touched on the new GA support for WebSocket in API management. You can probably tell that API management is a managed service as an alternative to Ocelot. I'll expand on that. So, other options. So before I talk about API management, there's other open source tools such as Envoy, and I believe that Microsoft has updated their API gateway technology from Ocelot to Envoy a year or two ago, relatively recent, because I haven't deep dive into Envoy, but Envoy has its own advantage. I think the main reason was because of the WebSocket support, because back then Ocelot didn't support WebSocket. So you can check out Envoy. That's an alternative if you like open source and you're not from .NET background. Now, if we look at the platform as service offering on Azure, we have API management. It's great, especially when you try to monetize your APIs that you want to make it profitable, or you want to charge your consumers for your API. So for calling your API, then the better choose a managed service. So that way you offload the a lot of under hood things, like how you manage the scaling and how you manage the security to a provider such as Azure. So you can focus on building your the orchestration logic or the fan out logic of your API gateway. And the alternative is application gateway. I'm not gonna dive into the difference between API management and API and application gateway. You're welcome to find out yourself offline. And if you have questions, you can chat with me. And as always, you can deploy your API gateway in your Kubernetes cluster. The out-of-box ingress controller, you can use libraries such as Ninjax. Right. So the second element I like to introduce is the VNet. So we can introduce VNet so that we can place our microservices within a fence, so that we can protect it by applying the security exercise at VNet level rather than the microservice level. So basically, we expose the API gateway and we enclose the other microservices. This ensures that the traffic flowing inside your fence are backed by your VNet provider rather than via public internet. And Azure VNet is a really great tool to use to enable all this from happening. Cross-service communication need to be done by some messaging system. The pattern behind this is called Saga pattern. So there are two different subcategory of Saga pattern, or different implementations of Saga pattern. One is by choreography. So what choreography means is that another service is triggered by the primary service, and they trained up. So by that, what it means is that, for instance, in a typical e-commerce system, what you can have is that when the order is created, it's looked after by order service. Then via the event channel, you fire off a signal, and then your customer service is going to be going to react to the order created event, and it might reserve your credits or fail the transaction if it detected as fraud or whatever. And then subsequently, it fires off another event via a customer event channel, and then your other service can react to it. So this way, your service are trained up and linked up in a choreography way. The alternative is you can do orchestration as well. So what orchestration means is that you have centralized message broker that looks after each individual channel. That the orchestrator will, look after each individual service and train up the event in a single place. And that way, when anything goes wrong in the orchestrator, we can look into the orchestrator itself rather than going through the trained up services like solving the puzzle. So each of these two implementation of Saga pattern has its advantage and disadvantage. It really depends on how your system, how you build your system, and how you want to look after your system. We want to use event sourcing to support us in implementing this Saga pattern. And so what event sourcing means that you're going to have a choice of events, and you can reply and you can audit those events in different states. And apparently within the Saga pattern, there's need to be a pub/sub service that's supported. And I want to highlight challenge in the cross-service communication, which is caching. So as I mentioned before, if one of your service relies on an external service, then we need to worry about how we're going to deal with another service going on fire. If another service goes down, well, apparently we need to find out why. To mitigate that, one solution is to have some caching. So that when the external service goes down, we still can get some data that is cached as the response. But we need to be careful in this solution that we need something. We need a circuit breaker. When something goes wrong, we stop the traffic, and when it's reconnected, when it's the external service has been reconnected, we want to establish only a portion of your API calls. Well, as we still disable the others, and then we slowly ramp up, and we need to refresh the cache as well. So I'm not going to expand too much on this, but this is just 2 cents from me, so that we need to be careful when we implement our cross-service communication. So I touched on different elements of a microservice. So to implement them, we can use a lot of services on Azure, and here I've listed some of them. So there's VNet to protect our services, and there's Key Vault where we can track our secrets in and reference in different services via managed identity. And there's different options for messaging service like Azure Service Bus, simple storage queue. blob queue, and we can use Event Hub if you are doing an IoT service as such, and there's Event Grid. Now, a simplified version of a microservice architecture looks like this. So usually you have your API gateway. This is very similar to Microsoft's example, but in a more simplified way. So via a PubSub pattern, we can talk to a service bus. That service bus doesn't have to be placed within your VNet. It can be outside. And if your API gateway support WebSocket, it's great. It can all be done via the API gateway in a unified way. Otherwise, the alternative is Signal R service, which is a managed WebSocket service offered by Azure. It has its own way of broadcasting and establishing the connection between client and server. So it can be a great alternative to solve the WebSocket connection if your API gateway tag does not have WebSocket support. And we can have cross-cutting services that look after different bits and pieces, like App Insight looking after APM, application monitoring, Key Vault to store our keys and secrets, and we can use managed identities to establish the identity validation between different services. All right, so now I'm going to show you some code snippet to show how we can set up Ocelot in a .NET application. First of all, we add the package, easy. And as how we deal with the normal application setting, we can add Ocelot configuration in a JSON file and have it loaded on different environments. All right, and then we need to do some configuration like what we do with other libraries, no difference from other libraries. So we add the service and then we use it. Here we need to be careful because when we try to use a library, it needs to come in order. So I'll show you where we use it in our configuration method. And if for developers from .NET background, we usually like Swagger, which shows our API definition. In order to show our API definition on Gateway, we need to add some libraries and do some configuration. Here shows how you do it. Add the package, add your service, and then use it. Again, the order of the services you use matters. I'll show you where to add them. And if you want to add authentication, for example, want to use JWT, then this is how we do it. If you choose other authentication schema such as cookie schema, is similar. So basically, we add some package and then we add our schema in our authentication scheme. All right. So once we've added, how we deal with it in Ocelot is like this. So first of all, a basic Ocelot configuration look like this. That it gives you a definition of gives you option to define your upstream pattern and downstream pattern. The upstream pattern means that how external word call your endpoint and how it will be coordinated to the downstream service by the downstream template path. And you can define the ports and so on and so forth. Now, the authentication that we added earlier need to be recognized as well. Otherwise, it won't work. So the way to say basically to let Ocelot recognize this by add the authentication option configuration here, and we can add the provider key. Sorry, so next one. And apart from the normal authentication configuration, we can also allow a header transform, which enables us to have the your authentication schema validation in one place. In our case, it's Ocelot, rather than spread it out in different individual services. And Once we've validated your JWT token, we can extract the claim out from it, and then we can attach it to the traffic that we offload to the internal microservices. And it's done in this way. I'll show you the code in a bit. Now, with Swagger, in order to make the authentication story work on the UI, then we need to add some configuration. Here's how we add it in each individual microservice. Now, so enough talk and the slides. Let me show you the code. So here I have a piece of code that I host on my GitHub repo. You can check out later if you like. Now, we do have an infrastructure. I love Bicep. Bicep is a superset of Azure Resource Management templates. I'm not going to expand too much on this, but if we visualize it, what we will see is in each microservice on Azure, we spin them up as a web app. So here's my service 2 and my service 1. You can move them. And then we have an API gateway that talks to different microservice. And we can see that we reference key vault for keys and secrets. And we can connect to cross-cutting services like App Insight as well. Now, let's jump into the code directly. So we have an API gateway, which is a .NET app, and service 1, which is another .NET app, and service 2. Now, so as I showed you on the slides, we can see that in our API gateway, we're gonna have a Ocelot's definition file in different environments. The thing I want to point out is that in your production environment, you want to map your service correctly. By what I mean, for instance, if we're using Azure, Azure service only opens up port 80, so we need to map the port properly, and we need to replace the host to your actual host. And if you especially when you have a DNS service, you need to make sure it's mapped properly. So a good way to do it is in your DevOps pipeline. You generate this Ocelot JSON based off your development definition, and just replace bits and pieces. Now, as I said before, we need to use the services in order. So I like to add it towards the end of the config method after we've enabled routing and authorization and endpoint. And the other thing is, if we quickly look at service 1 and 2, what we will see is, first of all, I'd like to show you the Swagger configuration. The way we use Swagger is pretty simple. But there's one thing I need to show you is that in order to show the Swagger definition in an amalgamated way on your API gateway, we need to add this JWT schema and configuration in each individual microservice, rather than at API level, API gateway level. Then how can API gateway fetch the definition of your subsequent service Swagger? That's done by defining a Swagger key and a bunch of Swagger setting that point into each individual service Swagger file. You will see that in action shortly. Now, so enough talking on the code. Before we jump onto the actual Swagger interface, I'd like to show you one thing is this. So here I have prepared an endpoint where we can log in, and it generates a JWT token by composing some claims. I have a special claim here. Just remember this. We're going to see it in action shortly. that we want to extract this claim out and show it on a subsequent service by transforming the header. Now, transforming the header means that we want to pass that value on to our header. Here, I try to pass it in a different service, and we want to see it happening without us changing the value in the header. Okay, so let's go to browser. Here, I have a service hosted on Azure, and from the entry point, we can see this is my Swagger of API gateway. Now, by the setup that we did, we can see that I can choose different service to see their definition. And from the glimpse we had before, we know that we have different endpoints sitting on service 1 and service 2. So essentially, we sit on this single place from, let me actually zoom in a bit, from API gateway, but we can see the definition in subsequent services because they're pointing to subsequent service Swagger documents separately. Now, if we go back to service A, let's have a quick look, see. I just want to convince you that it's actually talking to different microservice because we don't have any logic on at API gateway level. So it's coordinated traffic very well. We can see the result returned from the individual microservice. Now, if we switch to another service, we can see that we can get the response from another service. All right, so let's go back to service A and we try to get the JWT. But before we get that, let's try an endpoint that requires authentication. So if we try to call it, what we see is that we get unauthorized because this endpoint required authentication. That definition was in the Ocelot JSON file. Now, if we try to authenticate, let's see what we're going to get. So we add a username. I didn't do any validation, so I can add anything and add some password here. And so now we generate a JWT token. And as I said before, if we go to jwt.io, oh, sorry. If we observe this JWT token, what we will see is that it has a special claim that we want to transform by Ocelot definition. Let me make this bigger. And there we go. Here it is. Special claim for testing purpose. Now, if we try to authorize here, I hit authorize and I close, we can see that this time we get a hello world from service A this time. That means that the authentication is passed. Now, if we switch to service B, what we will see here is an endpoint that we want to try the header transform. So if we tried it out, what we'll see is that we get the special claim from the JWT token rather than me putting in. So no matter what I put in here, it's going to be ignored. So that's the beauty of Ocelot. So another bigger impact of this API gateway in how it manages the claim is that for any user identity relevant data, we need to put into the JWT token. We can fetch it out in the API gateway in a centralized place, and we offload the key information such as user's email to the subsequent microservice, so that in the subsequent microservice, we don't need to validate the JWT token again. This gives us a very flexible and way, and it will achieve a better performance for each individual service. All right, so that's my demo. For the in the interest of time, I'm gonna skip showing you all the services on Azure. And let's get back to my slides. So today we have talked about monolith versus microservice. I pointed out that monolith is not bad. It's slightly fading out, but it's not the beast. And microservice is not perfect either. We need to watch out for certain bits and pieces. Otherwise, microservice can be a monolith microservice, can be a beast. So, and then we move on to a deep dive to microservice, and we covered the key elements in the microservice architecture, and how we can build up our microservice solution. And we also specifically looked at the services on Azure that can help us to establish our microservice architecture. Then I also run you a demo as a proof of concept of the text that we chose, especially Ocelot, to how we can build a microservice architecture. All right, that's it for today. I want to say thank you. And here is the references. Thank you. Any questions? So I'll stick here for a while. I'll stop sharing, but I'm here. So I hand back to Sam.
Thanks, Patrick. Thank you very much. It was really informative session, especially going deep dive into the microservices architecture, pro and cons and up and downs in the microservices architecture. Really good. And at the end, followed by, the kind of, as you mentioned, POC implementation using Azure services. Very interesting, very good. I hope the guys in this session live with some key takeaways, taking in the next journey of building microservices APIs. Cool, really cool. Thanks for that, Patrick.
Thanks, everyone. You do have my details on link. You have my LinkedIn handler and my my Twitter handler, my LinkedIn account. So feel free to drop me a message if you have questions. Thank you.
I don't believe we have received any questions so far. I can't see. Arafat can help me if there is any and pop it out on the screen. Yeah, otherwise, probably we can wrap the evening. And thanks again, Patrick. It was really good session. So as Patrick mentioned, also his contact details is available. So please get in touch if you need any help or if you need any follow-up information details with him. I'm sure he's more than happy to help you out. Otherwise, please come along for our next sessions. And again, we have a special thanks to you all for sticking around, especially to our guest speakers, Patrick. And thank you very much, everyone, to all of you for attending. Really appreciate everybody who comes along and support our community and our events. Thank you very much, everyone, for your time tonight. Yep. Until next time. See you.
See ya.
Yeah.